Okay. So, a very good evening to everyone, whoever is seeing live, and to all people, eminent personalities over here. Uh, Queen Elizabeth II once said, "At its heart, engineering is about using science to find creative, practical solution. It's a noble profession." And Albert Einstein once said, "Scientists investigate that what which already is, and engineers create that which has never been." So, welcome you all to a live session conducted by Instrumentation Department of SRM University to talk about instrumentation, to talk about the department, to talk about what are the future prospects, career aspects is there for an instrumentation engineer. Hope you all who are watching here are safe, you and your family are safe and healthy. Don't forget to wash your hands and maintain a social distancing. That's more important. And a big thanks to Mrs. Asunta, Professor Instrumentation, Electronics and Instrumentation Engineering, SRM University, for coordinating this. And we will get on to our first speaker, who is Dr. Neela Juliet, with HOD, Electronics and Instrumentation Department, SRM University. She has 25 years in the professing, the teaching thing for in SRM University, and she got a lot of awards and a lot of publications under her kitty. And she is an inspiration, of course, for all of us. And if you want to know more about her, just Google her name, and you can see a lot of publications and whatever awards that she has received. She's going to first talk about a brief about what is instrumentation to all of you. So over to you, ma'am. Thank you.
Thank you, Ram. Good evening, folks. I bring greetings from the management and all the faculty members of SRM University. I'm glad to be with you today. Folks, you would have heard about computer science engineering, electronics and communication engineering, electrical engineering, mechanical engineering, and whatnot. I'm sure most of you would not have heard about electronics and instrumentation engineering. Let me say first, what is instrumentation? It is a science of measurement and control of various parameters that are dealt in industries, offices, home, and in day-to-day life, of course. Now, let me say what is electronics and instrumentation engineering in particular. It is a multidisciplinary branch. Why I say that is, it covers various subjects that are related to mechanical engineering, electrical, electronics, computer science, etc. Thus, it provides diversified range of jobs after your graduation. Folks, this is what is unique about instrumentation engineering. You must be questioning, where does this instrumentation engineer work? As I told you, it is a multidisciplinary branch. During these 4 years, you'll be studying many subjects. In particular, about instrumentation field, you'll be studying about transducers and sensors, automation, control system, embedded system, process industries, process control, etc. During your studies, if you get interested in transducers and sensors, you choose your career in a mobile company, aerospace company, aircraft industry, biomedical industry. All these places you need sensors, transducers to be designed and fabricated and to be deployed. Suppose you become passionate about automation during your studies. You can work in automobile companies. And you know very well, most of the industries are into automation nowadays. Very few are working in manual mode. And so your job opportunities are more in this field. There may be few who would get fascinated by control system subject. Of course, you will get a job in refineries, power plants, processing industries, production industries, etc. Suppose during your studies, if you are interested in embedded system, then opening could be in fabrication companies or fabrication of integrated circuits, microchips sectors. I heard from my students, those who graduated, those who are working in the software sector, these instrumentation engineers are assigned projects based on instrumentation engineering subjects, it seems. This is what is unique about instrumentation engineering, folks. I'm sure during these holidays after your exam, you would have gathered lots and lots of information by browsing, and you would have come across certain technical buzzwords. I do not know whether you know meaning for it or not, but I'm sure you would have memorized all those buzzwords. Let me list some of it: automation, big data, machine learning, image processing, video processing, machine data mining, artificial intelligence, robotics, smart industry 4.0, Internet of Things, you call it as IoT, microelectronics, etc. I would say that by doing electronics and instrumentation engineering, you can always top up in any of the topics that I mentioned earlier. Finally, I would conclude by telling that only very, very few colleges offer this branch. So grab the opportunity given to you at SRM University. With these few words, I turn over the show to Ram. Thank you, Ram.
Thank you so much, ma'am. That was indeed a very good introduction about what is instrumentation and what is actually the 12th standard students will look for the buzzwords. So the students who are listening to it and the parents who are listening, you got this as instrumentation is a very interdisciplinary course which covers. And post Corona, it's now even people are moving towards digitization and industries are upgrading themselves. Now I think so instrumentation is gonna have a great future. So next, it takes an immense pleasure to invite our next speaker, Mr. Neela Mani, who's a senior director at Cognizant, CTS, popularly known as. He's a graduate from SRM University, instrumentation control from 1997 batch, and he went on to do his MTech from IIT Delhi in 1999, and he hold a PhD too from IIT Madras. So he's actually a university second rank holder in his undergrad. He's a department first rank holder in his postgraduate, and best outgoing student award in 1997 and best alumni award in 2010. And he has an experience of over 20 years in global IT sector. So it's taken immense pleasure and honor to invite you and speak about instrumentation to you. Over to you, sir. Legended, sir.
Yeah, thanks, Ram, and thanks, Dr. Neela, ma'am. Are you able to hear me more? Is my voice clear? Okay. And let me present. One second. Okay, so are you able to see my screen? Okay, so thanks for the opportunity, first of all, and it's great to be in the midst of all the new budding engineers, and thanks for the opportunity once again to be part of this forum here. So I thought, okay, probably I'll give some perspectives in terms of a lot of people, as Madam was mentioning, Madam was mentioning, a lot of different views and perceptions about what instrumentation means. And being an instrumentation engineer for almost done my UG, PG, and right now in the working sector, I mean, in the industry for almost 20 plus years. What are all the different things that has brought in, what we can bring it to the table is what we will be looking at. So I thought, okay, how do we really look at, if we really quickly do a fast forwarding to tomorrow and see how much relevance it is to what we are speaking here. So that's what we'll be seeing here in next 10 minutes. I'll start with a very short story which everybody knows. So 6 blind men, and then trying to all are blind, trying to touch different parts of the elephant, right from tusk, trunk, ear, and leg, and then belly, and then tail. And then everybody tries to feel how the elephant is. And because they are blind, they are not able to see the entire elephant. So everybody has his own version. And we all know that everybody has their, so one person felt it as a snake, it is looking like a snake, the elephant. And the other person was saying that, okay, it's a fan. And so on, trunk of the tree, the wall, and then the rope. So with all these different perspectives put together, uh, the moral of the story here is obviously they're all blind. They're not able to perceive what is really in front of them. And obviously, if they all had eyes, everybody would have said the same answer, that the elephant. So it's a really an eye opener for them if they really would have had that extra sense, which can be brought in by the instrumentation that we can talk about. And at the same time, the different perceptions that you can really carry forward. Obviously, every engineering stream is very important. And obviously, how do we really see the future? And what are the things which is happening today, which is going to lead to the future? And how equipped we can be in terms of for the future jobs, and how much we can contribute to the future economy as well. So that is what we'll be looking at. So with this story, if we just try to correlate 25 years back, how the engineering, or 30 years back, how, or maybe a decade, 50 years, if you go back. So everybody had their own flavor of engineering. For example, if you look at mechanical engineering, looking at machines, and then automobiles, and then power sectors, which is electrical engineering. And with the advent of, there are so many other streams which are there. And with the advent of the internet, everything right now, the computer science stream, which is coming into picture, and when it started connecting everything, there is a lot of changes which have happened in the industry, and the lines between each and every department is actually fading out. What I mean to say that is, between mechanical and civil, there is an overlap. So now, the perspectives are slightly different from each and everything. So the specialization in terms of those areas are very much needed for the industry. But what is that which can change, which can be a game changer? So the big picture, like how we looked at the entire elephant, if we had a big picture here in terms of looking at all these engineering streams cutting across horizontal, across each and every stream, and looking at that and seeing a big picture can give us a big edge towards how we can step into the industry after finishing our engineering degrees. So what the big picture view is all about, so you have all these streams. For example, if you take mechanical, or you take automobile engineering, you take electrical engineering, you take electronics as a stream separately. So all these things where, if you look, it needs instruments, sensors. So I would like to interchange these two sensors, because sensing is what we are talking about here, and also the control of the sensing, which is there. So this is going to cut across every mechanical aspects of it. So you need to understand the mechanical concepts, the mechanical engineering basics of those things, and similarly electrical. If you're going to design a sensor which is going to measure something electrically, you need to have some fundamentals behind that. So you need to cut across all the engineering streams. So that is going to give a big picture view. So that is what the instrumentation engineering can really give, and to start with. Now, what is that we are going to do with this view? Okay, so that can be the next question. Okay, now we can see very clearly that I got the big picture view. So how that is going to matter? So the way it matters is going to be in terms of how are you going to look at this, the industry, whatever the needs which are, and then how it is going to be really going to step into the future. So we have seen multiple industrial revolutions, starting from the first, which is the first mechanical loom in 1784, and then followed by the second industrial revolution, which is almost just before the 1900s. And after the Second World War, all the third industrial revolution, which started using robots and then electronics, starting the personal computers, and then finally we are into the fourth industrial revolution, Industry 4.0. That's what it is called as, and everything here is connected. So when we say here connected, it means that every device, everything, whatever is surrounding us, whether it is right from your sound box, whether it's your phones which are getting transformed, everything is connected. And your microwave ovens, your doors, your home automations, whatever the devices which are at home, and not only that, even your the human measurements which are there, when we are talking, when we are seeing, how we are behaving, how your posture is, everything. I mean, whatever is there is getting connected right now. So it's right from human, machine, everything is getting connected. Everything is having ears, everything is having sight. For example, if you're taking a speaker and putting your ear on the sensing, the element on it, it becomes an Alexa or a Google Assistant. So it needs a sensor, it needs sense. Sensing is going to be the key, which is going to be connecting everything. So you need to have the big picture. When you have the big picture, you can understand that right now, if I have to talk to some device, that device needs to have that sensing. So if you look at instrumentation as a stream, right now it is getting matured. I mean, a lot of things are getting into the instrumentation, because previously the process instrumentation was the key thing, because industries like mechanical, electrical, communication, even biomedical, they sense and measure. We need to have sense, measure, and even control. For example, rocket launching, you need controls in that, and you need sensors for that, because if even if you tilt a little bit of off, you are going to miss the target. And in missiles, your robots which are there, all these things need control. So those were the hardcore instrumentation which is there. Now what is happening is the instrumentations are getting connected. The very term of Internet of Things, where you are connecting everything, needs a lot of instrumentation. What we are talking about is close to 75 billion IoT devices by 2025 across the globe. And not only that, when you are sensing it, you need to process the data, where you got some data. And one more thing I just wanted to mention here is, before 2000 or even start of 2000, if you look at it, people used to key in the data. So the data was very minimal. And the people used to process forms, and computer was used to do some automation, billing, etc., all those things. Now with the recent, all the connected devices, the connected instrumentation, what is happening is every machine is generating the data, everything is generating the data. So you have to process the data. You need to understand how an artificial intelligence can be used to process the data. Machine learning, how it is going to learn the data and then do some predictive analytics over it. Bots that needs to, I mean, the bots can be software bots which is going to sit and automate some of the tasks. Madam was talking about automation across the industry. So all these things are possible today. So we are talking about smart cities. Even governments are what Wi-Fi across the board. Everybody is connected. Again, you need the very typical thing is your mobile phone. What I mean, it is having, I think, n number of sensors, innumerable number of sensors, which is there. Right from the phone is getting, you are having an eye for the phone, which is your camera, and it is not only that, it starts measuring your steps with the accelerometer which is there in the phone. That is a lot of data which is getting produced. So with all these things, the wearables, your Fitbits, etc. So the smarts, right from smart home, connected healthcare. In the healthcare industry, that is getting transformed heavily. So by just having an Apple Watch, you can find out what is the ECGs can be generated and sent to the doctors directly. Though we are just very few years away from doing that, directly going and storing that. IIoTs. So I think the world, we are talking about the world here, where you can really go and then conquer it using these kind of technologies. Just to summarize, I thought, okay, I'll give a brief picture about, just if you take a human, what are all the things which we can really extend. I'm not even talking about extension of our thing. So a lot of people would have seen iRobo, all those things. I mean, all the science fiction movies. But what we are having today is all science fiction. If you look at it, you can use your fingers for measuring how much width of a particular thing is. Fitbits can generate how many steps are there. So when we are saying measuring, processing, all those things deals with instrumentation. And it's not only that, when you are talking about it, you need to understand how the pulse is generated in the human body. I mean, in order to understand, when you are talking about, I'm going to put a sensor for that. So you need to understand the domain. So that is going to cut across not only biomedical, mechanical, across the board. Again, I want to reiterate the same point which I was there. Smart shirts which can your heartbeat rates and everything, whatever is there, biomedical thing which you can do that. Shoes can even have sensing, where you can say, okay, whether if you are having a diabetic, right? I mean, there are foot ulcers which can come. So how much pressure you can put a sensor on the shoes, and even Nike is having one. That's what I've given here. And socks. Socks is the least thing that you can think of, right? And even that one can, I mean, there are sensing units that have come there where it's generating the data that needs to be processed, understood patient wise, individual wise, where you can put in your AI, IoT, AI, ML into that and see whether this person is going to be getting a diabetic foot ulcer in next 10 years. You can do that. Similarly, rings, all those things, so which is there. So it's all, everything is connected apart from whatever is there, which is God-given body for us. So now, with all these things, now I just wanted to move into another question, saying that, okay, so we have seen all these things. Now, how do I know what is going to be there for in the next 10 years? So there are some indications from various research which is across happening, especially the business, the organizations do a lot of research, consulting companies. So one is, some of you might have heard this Gartner name, which is very famous. And from a technology perspective, they predict what are all the emerging technologies for the next 10 years. So what I wanted to give you, leave you with is, I want to show you two graphs. One is from 2010, and 2010, what Gartner has predicted. And because 10 years has passed, now we are in the reality, 2020. And right now, I'll also show you the graph for 2019 also. And that can give you a glimpse. I'm not saying this will be 100% accurate graph, because obviously only God can tell that 100% accurate. So it will give you an indication of where we are with respect to that, and what will be the industry going after 10 years. So that can give you a glimpse of how you can get equipped by looking at some of these big picture ideas that you can get out of these kind of streams, which very few people know what it is offering today, and then sculpt your future accordingly. So this is the 2010 graph. You just have to quickly, a few seconds to go through this. This is this is about emerging technology. So the way the curve goes is, these are the initial, when the technology is first initially, it's a breakthrough technology which is coming onto the market. So the market, how it is, that is when it is hyped very heavily. And then after that, with initial hiccups and other things, it gets fine-tuned, and then finally it goes and then settles into the industries, and then it becomes a part of daily life, the technology. So now, with respect to this curve, 2010, this was what is special. For example, mobile robots. Today we are having swarms of robots, everything, whatever which is there today. 3D printing was there as at that point of time. Today we can go and even buy a 3D printer for your home. Today, speech-to-speech translation, it is there. So augmented reality, which is there. Cloud computing was one of the things, which is e-book readers, biometric authentication methods, mobile application stores, which is predictive analytics. I talked about it, some of the sensors where you can use the data to do that. So if you look at this stream, pretty much, I would say maybe 40-50% of this, whatever is given here, is right now, today it is reality. That means that whatever is there 10 years before, that became a reality today. So, and all these things have some common things, which is without your sensors producing the data, which is being completely, it is impossible to do that. And if you understand how the data is taken, getting processed, how it is given, and then finally using the mobile devices, it is being delivered. So that is going to be that is where we are today. So now I'm going to take you to the future, which is what is the graph for 2019. So if you look at it, the 2019 graph, if you just one thing is autonomous driving level 4. In fact, the previous graph had the autonomous driving, which is your driverless cars, right? I mean, automatically drives. So the level 4 and level 5 are there. So I'll just touch upon that automated cars also just in a moment. And drones, light cargo, Amazon is already talking about it. In fact, they are testing prototype today. So tomorrow, maybe 10 years down the line, you just place the order, the drones will deliver in front of your home and then just go. There will be no more people. Flying autonomous vehicles, multiple things. So all these things, if you look at it, there's a common theme which is coming out, which is there's going to be a lot of sensors which are going to be coming up, new kinds of sensors, very accurate thing. Not only that, you need to process the data for the sensor. You need to generate the insights, business insights that is needed for the industry, and then you are going to be predicting how things are going to be. All those things are going to be part of this this engineering which we are talking about here, and 3D sensing. So now moving on, this is a Tesla vehicle. You can see that it's very intuitive picture where a dog even can just be a driver, acting driver, not really driver. So what it really requires, if you just look at it, this particular car, right? So you see all these things which are these are all possible only by the sensors that we have. For example, lidar is one very, it will measure the contours which is there for people who know. So it uses the light detection and ranging, and the radars which are there, which produces the waves, radio waves, and then you get the three-dimensional view, surrounding view. So the parking, even today's car, whatever we are having, is having the parking proximity sensor. So you can, so even for driving, making this car, it needs a very extensive and exhaustive knowledge of instruments and what are the parameters that it is going to give, and how it is going to be really processed and in real time. So that is also very important in real time. So you have to think in terms of, okay, if I'm going to detect somebody who's going to be in front, on the side, and there is the speeding car which is coming in front of you, how my car is going to navigate. So imagine how many sensors you need, how many sensors are going to be integrated, the data that it is going to be received, and how it is going to be processed in real time, how I'm going to really look at it and then give a feedback, the control part of it. So all these are possible. You get that complete big picture in terms of that. Finally, I'll just leave it with one note for one quote from Bill Gates. The advance of technology is based on making it fit in so that you don't really even notice it. Actually, today, you don't really notice that, okay, cell phones have become an integral part of that. It's not the phones which were there in the past where you have to dial and then it was using only the phone. So what I would leave, the final statement I should like to make is, so your future, you can definitely change, you can see the big picture through just using this particular stream. And this is a great opportunity for you to really look at it, understand everything. There is a saying that jack of all trades and master of none, but this particular stream can really make you jack of all trades and master of all. Thank you for the time, and thanks. Back to you, Ram.
Thank you, sir. That was, a splendid presentation, with starting with the historical references of how the industry has been progressing with the future. So you cover the past, the present, and the future. So it's actually amazing presentation, sir. So just taking few lines from that, and then to the kids who are watching, sensors. So when you say sensors, I just remember, all you kids have watched Iron Man, and that is Jarvis in Iron Man. So just go type in Google, what are the sensors that Iron Man is using to build Jarvis. So that is all for you, sensors is there. And just Google out how many sensors are there in a self-driving car. So that will give you an enormous opportunity, the sensors right now collecting data and doing it. And me being an instrumentation engineer passing out of 2015, I remember two of my friends right now who did instrumentation from this department. One is right now working with creating self-driving cars, and one is actually doing a PhD in robotics. So that's where this department has a huge future for that. So thank you so much, sir. And I would ask you two questions to you. You actually a 1997 batch, and that actually makes me curious to ask what made you to choose instrumentation as a career, as a department in 1990, way back in 1997. What was your
Okay.
inspiration, sir?
It's a good question, Ram. And in fact, during those times, the number of streams were also limited. And so the first thing I was not really sure about, because at that time there was no internet, Google this much, where you can Google and then find out. There is no, I would say probably seniors whom you can go and then talk to them and then find out, okay, what is this stream all about. The one thing which I heard on the instrumentation when I was exploring this one was, they said that this is going to be cutting across all the streams. It's not only going to be a mechanical oriented, because you can see that it cuts across a mechanical stream, electrical stream, electronic stream, whatnot, even civil, right? I mean, you need sensors for structures, buildings. Today, if you're talking about home automation, right? A lot of things which are coming into that one. So that excited me, because I don't want to restrict myself to one particular stream, because I wanted to explore each and every part of it. So that's one thing which motivated me to really take this up. And truly to that, that's why I was able to, even in my presentation, if you look at it. So it will give you an edge over so many things, because when some people talk about, for example, if you're developing a force sensor and then trying to get how a person is going to walk, or what is the posture of that. Today, the gait portion of it is, even you can use that for a biometric, where how the person walks. So you need to put some sensors on that. Now, for understanding the force, right? How, right from Newton's laws, even, so you need to go into a little bit of mechanical and then try to understand that. And same thing with when you are trying to design a circuit, right? I mean, you need to understand, because your data is going to come. You need to understand how your data is going to be perceived, whether you're talking about an analog to digital converter or a digital to analog converter, whatever it is, right? I mean, you need to signal processing and the way you are taking the data and then trying to do that. And now with the advent of your computer science, you can use your AI ML to really see, predict, and see whether a person is, for example, I can quote one thing what where our organization was part of, where diabetic retinopathy images from Shankar Nethralaya, certain patients. So you go through it and then try to get the whether this person can get diabetic retinopathy in the next few years or not. So those are the things which are directly affecting the lives of the people, and definitely that's what has excited me, and still it is exciting me. Even though I'm in part of the IT industry, I am still very close to the AI, ML, and how the real-time sensing, as well as the how it can be processed better. So that's some area which I'm really working on at this point of time.
Thank you, sir. Thank you, sir. Just leave me with, if you all guys were watching TV, I recently, there was one advertisement where I think it was Meenakshi Hospital or Apollo or Fortis, where they claim that they are the first one to come up automated something. So in Tamil Nadu. So that's where, I see a lot of instrumentation is cutting across all the departments. It's there in healthcare, it's there in automobile, it's there everywhere. So thank you, sir. And one last question. And if you say in one sentence to the people who are watching here, to the kids and the parents, why would you recommend instrumentation as department to a student to pursue?
See, I think made it very clear. It's I would put it as a connected, versatile engineering for the connected world. That's what I would say, call it as. Okay. So if that is what you are looking for, the future, I think this is the department. This is where we need to really look at. Having many people work on, do a lot of research. One more thing I would like to add. I answered that in one sentence, but I like to add one more thing. People also should understand that the devices sizes are becoming very less, and the processing power is becoming very high. So there is a very, very high opportunity for this particular stream to really come up with new ideas, even if you want to become an entrepreneur with some smart sensing devices that can be used. And with the advent of whether you want to integrate as an industry product, all these things are possible with respect to what we can do here. So I'd like to
Thank you.
probably
Yeah.
add that.
Yeah, sir. So with the amount of lot of entrepreneurship being promoted with Make India and Digital India, and I think so that will also will open up a lot of opportunity. Thank you so much, sir, for your time. And uh, next, we'll move on to another
Ram,
person who
before
is
that,
yes,
Ram, can I make a
yes,
mention? Mr.
yes, ma'am,
Neelakantan
yes.
is my first batch student. Of course, all of you all are my student. Neelakantan is my first batch student, and all those who are being showed up here have helped us in framing the syllabus. I just want to
Thank
make
you.
Great,
a
sir.
mention here.
Thanks for that
Thank you.
opportunity, man.
Thank you.
Really, it
Thank you.
was great pleasure to be with you, associated with you, and contributing back to the syllabus as well. Thanks for that.
Thank you very much.
Okay, thank you, sir. So, to all the people who are watching, to the kids there, if you are using laptop, if you are using, you might have seen there is a small sticker down with i7, i5, whatever processor, and that is something in Intel, a big name in the, in the system of creating VLSI and ECU design. So we have someone from working in Intel. We have Rashi, who's a 2017 instrumentation batch passed out. She went on to do her master's in BITS Pilani in microelectronics, and right now she's an associate design engineer in Intel, Bangalore. And Rashi, the question to you is how E and I have shaped your career. You have been passed to 2017, just 3 years, and then you went on to do a master's, and how instrumentation have actually shaped your career.
Okay, so yeah, thank you, Ram, for the introduction. First of all, I would like to say thanks to all of you here, and especially to Asunta ma'am for making this possible for all of us getting together. And yeah, so as you asked, Ram, like what made me choose instrumentation was like all of us who were there during the counseling session as an SRM it goes on when you enter the most like extravagant the auditorium PP Ganeshan auditorium. So yeah, I was like any other student, I was there. So but first of all, when I got into a SRM, so that rank and all was nice, and it was like the second day counseling. So I was very much looking forward to SRM because I've heard that obviously, like as compared to other institutes, SRM has a very nice and a culturally and obviously elaborately very nice syllabus to pursue any of the degree you want to go for, any of the stream, I should say. So yeah, when I went there, so me and my dad and my mom were there, and so we were looking up to all the streams. And one thing stuck to my mind, as Neelakandan sir mentioned earlier, that to do something different from the other streams, EC, like all these this were the IT, every other. And since I was able to go opt for any, I opted for instrumentation because, as my father told me and my mom, that this is something you're coming too far. Like I'm going 2,200 kilometers away from my hometown, so it's better to do something different. So I saw instrumentation there, and I was like one day before my counseling, I googled it and I checked what it is basically. So the number of opportunities and the number of companies and the pathway it opens up, it was much more than obviously the mainstream electronics that we all we all juniors, we all wish to pursue. So instrumentation was something that it gave me a path that I can do, obviously do something different from all others. And obviously the syllabus is so elaborative from SRM, and it has helped me to even pursue the further examinations that we have like GATE and even in MS. So that is something that choosing instrumentation gives you edge over others. And I'm very happy and I'm very glad that I took this chance of being different from others. This could have gone way down. I agree that sometimes decisions might not be as you've expected. But the instrumentation was one of my good decisions when I started my studies with. And not to mention even taking instrumentation has helped me to get into some of the subjects which were a little bit unknown to people when I saw people from bits pilani also, like my classmates were sometimes not sure, like okay, do we need to stress on the transducers here so much, sensors, because let's agree that even VLSI has much part of it. So people from EC background, they were not knowing like what it is, even triple E. So it was something that I was way ahead of my classmates, even in Bits Pilani. So I give all this credit to the choice that we all, basically all the alumni that we made to choose instrumentation as a career beginning. And yes, from there on, from BITS Pilani, I got campus placement into Intel. But instrumentation is the thing that I started with my studies. So yeah.
Great. So thank you so much, Himanshi, for Rashi, for saying that. And very all the very best for your future in Intel, and create a lot more designs to connect the world to bring in with sensors and
Yeah.
stuff. So thank you so much. So now we'll
Thank you.
move to another alumni from SRM University, from E&I Department, Instrumentation Engineer, a 2016 passed out. And you all know cars when it comes to ours is Ford Motors, and they are the pioneers in there in US with the T model. Whatever you see in McDonald's, that thing which is coming in, it is all by the Henry Ford. So Ford Motors always have an edge over in the automobile industry. So we have someone from working from Ford Motors Chennai. So she's Himanshi is a 2016 passed out. As I said, she's working as a product development engineer, design testing in Ford Motors. And the question to you, Himanshi, and again the same question I would ask you. The first question is why you choose instrumentation.
Yeah, okay. So thank you, Ram. Thank you, ma'am, HOD ma'am, and Assunta ma'am for the session. A warm welcome to all the guests, parents, to the students, and a big congratulations to the students because they are going to enter the new phase in their life. And so to answer the question, I think, again, so when I was in class 12, so we are all confused. Okay, what we actually, I had interest for science, but I always wanted to, not really sure where I want to end up, which field I want to work into, what will interest me. So I was thinking, okay, if I go for mechanical, so this was all going on in my head. If I choose mechanical, it will be very streamlined. If I go for aerospace, it will be very streamlined. I'm not sure if I like it, if I like the course. Maybe after 4 years, if I'll enjoy it or not. So I think, okay, why not go for something which is very diverse? Maybe in the course of, because these 4 years are not just about studies. This will actually help you understand. Like there'll be a lot of things that will come up in during this whole journey. Where you might like a new thing, or maybe you'll kind of leave the thing that you are liking. So it's a kind of an up and down journey. So maybe right now I like cars, but okay, I'm just going for it, and I find my interest into IoT, and I think, okay, I now have to switch into IoT. This is what more fascinates me. So I just left. I chose, okay, I'll feel like my tray is whole full of fruits. So I'll just go, I'll take the taste of everyone, and then I'll decide which is my favorite. So that's the reason why I just chose instrumentation. And then I think during the whole course is when I found, okay, I kind of have some interest into the automotive world and into I want to explore this more, and that is when I kind of turned into that field. But yeah, so because it's not only about, you have to keep a whole picture about what is going on in the world, because as Neelakantan said, the technology is evolving. It's evolving in a very fast pace. So you never know what is what right now we are using might be we are not using it the next year. So I think to keep it up to date and to get the flavor of what all is going on right now. So that was the whole reason why I chose instrumentation. So to keep my all options open after
Great.
4 years. Yeah.
Great. Thank you, Himanshi. You beautifully said that, keeping us updated, and instrumentation is one field which is striving to get updated, and always whatever we use may become absolute and other things comes up, and instrumentation, helps us to be on with the world movement. So the second question to you is, Ford Motors, we all actually dreamt of being in Ford Motors, and it's actually when we were there, it's one of the core company being for automotive. I also chose automotive as one of the elective in the instrumentation department I was studying. So we were like, a lot of people were rushing into, this automotive electives by Sam sir, we still remember. So I just want to know how you ended up, in a Ford Motor.
So yeah, I think so as I said, I was not sure where I want to go into. So I still remember in my second year, there was this friend, like a group of in my class, and I just went up to them and says, okay, I think we should do something. Let's start doing some projects or something that will actually interest us. So we just started, and then we started working on very small projects, and then we took up, okay, this we have completed. Now let's go for some inter-college competitions. So we started with that, but then slowly the whole journey, when you start to learn and explore things up and new things come up. Okay, now, okay, I have now done into competition. What is next? Okay, let's go for some international ones. So I think I would say this whole journey, there are some pillars, okay, or there are some helping hands that actually help and mold you to get into where you actually want to land up. So I think it's because of the teachers, the professors, the support of the department. Because I remember, like in my first project, it was a very small one, so we used to able to complete it during the class hours and like after staying for an hour or so. And then we planned to go for some inter-college competitions, and I wanted to stay in the department and work. So I went up to my class in charge and I said, "Sir, I think I need some more time to stay because it's not sufficient. I'm not able to complete my project. What should I do?" So he said, "Okay, it's fine. Let's go to HOD ma'am and talk to her." So we went and we told ma'am we are interested to work on this project, and I'm like I need some extension from the hostel. So she immediately gave me the permission. Okay, you take the like she gave me the permission. You work on the project and go for it. So whether it's going for some college, because you are when you are going for some competitions, you are missing on your classes. So you have to redo your practicals, then you have to keep up your lectures. So sometimes like we are kind of lag behind, right? So I used to go to the teachers. The only one thing they used to say is, okay, you go for it, irrespective of you win or you do whatever. We just want you to take part in this. Just learn. This will be an experience, and if you need any help, just come to us. And we used to like literally go to them and ask, okay ma'am, we have this problem, I missed this lecture, can you please help me? And they all used to help me. So that is when the motivation came. Okay, so there's something, because when we, like, I'm in UP and I'm like 2,000 kilometers far from my place. So what is that whole small group? No, it becomes like a family. When you know, okay, I have someone at the back to support me, then I can actually grow. So then I took like there are so many teams in college, right? We have a lot of like as drone, and like people are building cars and fast racing. So then this fast racing thing came, and there was this team called as 4Z Racing. So I was really like I saw it and I'm like, okay, I want to get into this team now. I've done projects, and like all the group, like my group, those project groups, and we said, okay, we want to get into it. And I went and then got selected into it, started working on it. And that is when I started liking more, okay, onto, okay, what is happening inside the car and what all the scope we have. And they really appreciate the knowledge that we bring from the instrumentation point of like we had that mindset because we were reading those subjects that was always there. So when you are discussing in this whole team, I think it was a team of 120 people, students, all from a different background. The thing that you bring onto the table is different. So everyone brings a different, like even from, it is sometimes different from an electrical point of view, because you have the kind of knowledge you have in instrumentation, like because you always have instrumentation cluster, right? And all the cars you have tachometers, you have gauge meters, fuel meters. So you bring a different thing to the table. So I think it all started from there, and then finally I ended up in Ford. So the reason why I told this whole elaborated story is because all the students never hesitate to ask, and I think the teachers, the department, everyone there is very, very, very supportive. You'll feel like a small family. Just ask them as you ask your parents, and I'm really sure that they're going to help you out. So that is what has happened to me. So this is how I ended up here with my whole family. Yeah.
Great. Thank you. Thank you so much. As you said, I'm just remembering, in my class in 2015 batch, our batch students as instrumentation engineer, we were there in all, from our department, there is people who will be in camera racing 4C, there'll be people from in Humanoid. And actually, indeed, our batch students are the one who started Humanoid. The whole team, and they went to US, and the two of my friends from instrumentation class, and they started the Humanoid team. And as you said, there are a lot of teams and projects. Coming back to the projects and getting OD to go to inter-college festivals and tech fest. I remember going my first year and second year itself to IIT, NITs, traveling all across Tamil Nadu to go to tech fest. And the department has been really supportive. And for the project, my final year project is, again, we want to build a prototype. So we built a prototype, a moving wheelchair, eye-controlled and joystick-controlled wheelchair, and it is still there. So it's always been a project, and the support from the department has been huge. So thank you so much, Himanshi, for the elaborate thing, and all the very best in Ford Motors. and keep rocking. Thank you. Thank you so
Yeah,
much for
thank
joining
you.
us.
Thank you.
Yeah, so now someone we have special who have joined us from overseas. Thank you, first of all, to join from overseas. We have Manoj, who joined from United States. Thank you so much. A brief introduction about Manoj. He is a 2004 instrumentation passed out from SRM University, and he went on to do masters in electrical engineering control system from University of Alabama in Huntsville, US, and he's working as an associate vice president in national discipline quality and performance manager in Corollo Engineers in Texas for over 14 years. And it's from a process industry. And just want to connect to the kids what he's up to. From my understanding, I remember when I was growing in a small place, I see a sewage water treatment plant, and there are a lot of sensors, there are a lot of things is there in my area. So when I read about Manoj's profile, so this is what has popped up in me. So we have an eminent person who is in the process industry for more than 14 years. So thank you so much for joining, Manoj. And the first question again to you is, as a 2004 pastor, and what motivated you to choose instrumentation?
Okay, thank you for that lovely introduction. I hope you all can hear me okay. Okay. So yeah, thank you again for the great introduction, Ram. And I want to thank Dr. VJ ma'am. I've known her for a long time now, and also Sasunta and you, Ram, for organizing this. Also welcoming all the students who are listening to this live and who will be watching this later as well. Also all the alumni, very nice to see all of you here, and excellent presentation, Sir Neela sir, and also Rashi and Himanshi. Thank you for that nice, your story on how you connected with instrumentation and SRM. I have a similar story. Mine is kind of simple. My father worked for MRF Limited for almost all of his career. And he has taken me to his factory many times. There are a few factories in Madras. And whenever I go there, he would kind of show the kind of work that's happening there. And what he told me was, he kind of explained what all the things happens and how the tires are being manufactured. And as I was getting closer to the engineering, my 12th standard, one of the things that he mentioned was as we were going through all the different engineering curriculums, I wanted to be a mechanical engineer like my dad initially, and then he explained what instrumentation is, and he was mentioning to me that there is a lot of instrumentation work that happens in the factory, but those are being done by mechanical or electrical engineers. So Mr. Neelakantan sir said something initially. Back in those days, we only had 3 departments: mechanical, electrical, and civil, right? Those were the engineers who came out and kind of developed the industry today. And there's a lot of things that connect between those 3 disciplines. And when I got into engineering, instrumentation was already out there. Back in the day, it was called instrumentation and control. And my dad explained how this instrumentation is applied not only in the process industry here, but in many, many different industries. So I had a glimpse about what instrumentation was all about because of what my father showed me. And many in my family have gone into the process industry background. So listening to all the stories from them, I always wanted to be in the process industry. So that kind of was the reason why I chose instrumentation.
Great, thank you. Thank you, as many of the students, even when many people are going to computer science as EC and EEE, did you actually regret after choosing instrumentation when you came to the department?
Well, I did not regret, but I'll be honest with you. I heard, even when I got into engineering in 2000, obviously, a lot of people were talking about computer science. And IT, not so much, but computer science, yes. IT was kind of new, so many people were kind of scared to get into IT back then. Computer science, yes, a lot of people wanted to get into computer science, and other departments were also there, electronics and communications engineering. had a huge success, and it was supposed to be the safe discipline because you could get into many different things. But me personally, I did not regret one bit because number one, I knew what instrumentation entailed because of what the syllabus that I already was made aware of by my father and other family members, and I also knew the opportunities that instrumentation was going to provide. Um, again, based on experience, obviously I knew more after I got into the industry and after going through 4 years of engineering, but even before that, I was very focused on what I wanted to do. I wanted to kind of work in a process industry, and so definitely no regrets there.
Great, thank you for being honest, Manoj. And I'm just curious, you being in the process industry for more than 14 years, just say me, what is your everyday work as an instrumentation engineer?
Sure. I'll kind of limit to what I do in the process industry. Obviously, there are going to be a lot more things that I'm not going to be able to mention here. So I work for the water and wastewater industry. And as you all can imagine, most of these process industries are now automated. Way back in the day, everything was being manually operated by operation staff at these locations. And if you have to turn on a piece of equipment like a pump, you would have to turn it on manually. I know Himanshi, you're working for Ford. I know, like I can imagine the production of a car. If everything was going to be done manually by people, the manufacturing of one car might take more than a year, but not so much right these days. So everything requires automation. So does a process industry. The example that Himanshi is a manufacturing or automobile industry, but even for a process industry, there are many processes that are involved within a treatment plant, and everything needs to be automated. So my work is basically as an engineer, providing design to automate that facility. As Mr. Neela said before, there are lots of sensors to measure flow, temperature, pressure, level, and also certain parameters. Because I'm in the water industry, there is a lot of nutrient parameters that we have to measure, like nitrate and turbidity and ammonia and everything. So which is what you're going to read for 4 years in your engineering curriculum. There are lots of instruments, we call it, just to have a generic name for it, a lot of instruments and measuring technologies on how those instruments measure those parameters. So that's step one. The step two is controls. These instruments provide feedback about how the process is working to a control system. And that control system, which when programmed correctly, can automatically turn on a piece of equipment or turn it off or run it for a certain amount of time and then turn it off. You can do a lot of things. And so my job is to design those systems. So I understand from our process engineer as to how the water treatment plant or the wastewater treatment plant should function. And then I show all those pieces, all those elements in a drawing, and then say, here you need an instrument to measure level on the tank. Here you need a controller to turn off the pump when the tank level reaches a certain level so that there is no overflow. So in a simple sense, that is kind of what I do. I create design for these systems. And there's a lot to it, that I can go on and on, but from for someone who is, all those listeners who are passionate about, these industries that you see on TV and what you read in the news, if you want to become a part of those industries, this stream will obviously take you there.
Thank you, Manoj. That was like, it's very understandable to even whoever hears it. So thank you for keeping the jargon low and explaining it so simply. So thank you so much for that. And and the next question is, you went on to pursue higher studies in US. So I just want to know, what motivated you to do that, and how the US students, your master's students, see you that when you said that you are an undergrad in instrumentation. in US. So how that was being perceived there?
Sure. Obviously, the reason why I decided to pursue my higher studies was a couple of things. One is motivation from my family and from my staff at SRM. All the way from Professor Ramanujan and Dr. Vijay ma'am, and they all motivated me to get my higher studies so that I can learn more. Also, from a personal standpoint, if you want to excel in an industry, you have to have an advanced knowledge of those elements. And so from going through SRM, there was 4 years of learning a lot of those basic foundation of engineering. In the first year, we studied everything from civil, mechanical, all the way to few instrumentation courses. But it is very important because, as many of them on the call here mentioned, it is so connected. In order for me to work on this water industry, I need to know some civil engineering because there's a lot of things that we do out in the site. So I would need to understand how civil engineering plays a role. I would need to know how, obviously, mechanical engineering is huge because I would need to understand how I would have to install an instrument on a pipe and what are the devices, valves, and actuators that I need. So I got 4 years of good, solid foundation of engineering, both generic and instrumentation engineering. And then I felt like if I have to do anything more, if I have to learn more, I'm already in the mode of learning. It is not going to be easy to learn after you have worked for a certain number of years. It might change how you think. This was the right time. And again, from support from everyone at home and from the university, I was able to pursue my master's degree in the US. Second question is, how did the instrumentation discipline in the bachelor's degree help me? I'll be very honest with everyone here. When I went for the job interview to Carollo Engineers, they only saw 2 things in my resume. The questions weren't too many, to be very honest. They saw the word instrumentation engineering in my bachelor's degree, and then they were surprised about it because instrumentation engineering is not a bachelor's program here in the US, even today. And the second thing that they saw was I was a part of an association called ISA. I'm still a part of that association, and that's because of SRM Engineering College. They encouraged everyone to join this organization for instrumentation. It used to be called Instrument Society of America and underwent some name changes. Now it's called the International Society of Automation. But what it is it's an industry association. Most of you have heard of IEEE. That's for electrical. This is ISA for instrumentation. And that allows you to understand what's going on in the industry. There's a lot of training. There's a lot of opportunities to go and present in conferences. And so SRM encouraged all the second-year students when we got into the core instrumentation engineering to join ISA. So in your introduction about Dr. Vijay ma'am, you may have not mentioned this, but Vijay ma'am has contributed not just to SRM but also to ISA. She has won, I think, 2 back-to-back year awards for the Volunteer Leader of the Year and Mentor of the Year, not just in India, but ISA is a US organization. This is throughout the world. And so she has been a huge inspiration for me and many others to be a part of ISA. So when I went for the job interview, they were, number one, confused that I knew that I was an instrumentation engineer by nature, with my bachelor's program. And then the second thing was, they said, oh, you know what ISA means? They were surprised because they were expecting ISA to be a part of their career after we joined the company, but not before. So I knew what those ISA symbols meant. Basically, it's a standard. So there was a lot of general things that you would learn by being a member of ISA. And so those two were basically the reason why I got a job. I didn't have to say much during the interview. So again, thanks to SRM for that, because without those two, they wouldn't have been this impressed with my profile.
Thank you, Manoj. And the last question to you is what I asked Neela sir. In one sentence, if you want to say why you recommend instrumentation as a department to a kid.
I think I'll basically echo what everyone else has said. This is everything is going towards automation. And so this is that one discipline that will allow you to be a part of automating something in the future. Be it someone like me working in a process industry, or be it Mr. Neela sir, who is working in the IT industry but still associated with instrumentation, or be it Rashi or Himanshi, who are working in the manufacturing and automobile industries, or any other industry for that matter, who are not on this call. There is going to be automation in everything, and that's the future. And so if students want to be a part of that, this is the venue to get you there. And I wish you all the best.
Thank you so much, Manoj. Anyways, if you want to be a part of future, you need to. That's bang on. Thank you. So, as many of them are saying about ISA. Manoj was mentioning about ISA, and I was mentioning about few teams, and Himanshi was mentioning about 4Z. And there are a lot of things that's actually been there. International partnerships and organizations, teams, and everything is there. So, I request again, HOD ma'am, Dr. Vimla Juliet ma'am, to present what is instrumentation department in SRM offers, and what are the different accreditation, what are the different teams are available so that the students will know. Over to you, ma'am.
Thank you, Ram. Can you see the slide? Can all of you see the slide?
Yes, ma'am. I'm able to see.
Yes.
Thank you, all of you, for talking about instrumentation department. I think I no need to mention about my department again, but yet it has been scheduled to talk about the Department of Electronics and Instrumentation Engineering at SRM. Let me take you through the department. This department was established in the year 1993, and since then it has been growing strongly for the past 27 years. This was initially offering electronics and instrumentation engineering, and now it is offering master's degree in 2 streams, microelectronics engineering and electronics and control engineering, and we too offer doctoral degrees. This department is accredited by Institution of Engineering and Technology. This is UK accredited body. And these are some of the recognitions that is received in the university level. This department has a strong tie-up, and it is also serving as an industry partner with Skills Sector Council, New Delhi, for the benefit of the students. This department has an industry-powered lab by Mitsubishi and National Instruments. We run certificate courses, and these courses are run by the eminent industrialists for the benefit of the students. And we have a lot of memorandum of understanding with companies, and I have listed very few here. Because of this agreement, our students are benefited through internship, consultancy works, industry-related projects, and they do get jobs. And these are the 5 research centers we have established in our department. Students right from 3rd year, they get attached with any of these research center, and they do projects in these research center. And because of our students, we were able to achieve the following. We have got 80 publications within 5 years. And with the help of the students, we have filed 50 patents. Out of 50, it has gone to the publishing stage, and some of them have gone to the granting stage. And the students are having a lot of clubs and associations. One of it to be worth to mention is International Society of Automation. We are very active in that association. Students take up many official, portfolios in that association. Of course, placements are always good in this department. And some of them, those who don't get placed on campus, they go for higher studies, and very few percentage are going for entrepreneurs also. And these are some of the areas in which instrumentation engineers can work. And these are some of the companies which come for recruiting our students. And these are some of the software companies that come for recruiting. And all these companies, because our students are working in some of these companies, our own students come for recruiting in SRM University. And these are some of the sectors in which our instrumentation engineers can work. And for the detailed information of our department, you can visit SRM University, Department of Electronics and Instrumentation Engineering. And now over to Ram.
Thank you so much, ma'am. So, to end, I also, after completing my engineering work, got an opportunity to work in KPIT Technologies in automotive electronics. So that one elective that I took on automotive was really helped in my interview, the technical interview, because even the interviewer was really amazed, because there is an automotive electronics, there is a subject which is there under instrumentation. So that is one of the primary reason which got me into KPIT, and I'm happy to work. I was actually working for a client, Broadcom, creating AutoSAR, which is the next new thing in automobile. So I was a part of that team, and being an instrumentation control, I've actually given an edge over for other teams, and I can actually bring a lot to the table. So I was working in KPIT Technologies as a software engineer for 2.3 years. So the students might got broad ideas, why you need to choose instrumentation. What is instrumentation? What are the opportunities, career prospects available, in instrumentation department? And there are a lot of students, I being work predominantly with the youth and young students for a long time through my organization. Many of the students come and ask me, I'm confused about career. I'm confused, what department should I choose? I'm confused. So, I'm so happy that Manoj said a point which actually, resonated with what I did and what I actually do in my talk to the students. So Manoj made a point that I actually went and searched what is instrumentation. That is a key to start off with. So the clarity is something really important before you take a decision. So what I suggest to students is, whenever I go and give a talk, I ask them, you have something in your hand, which is the Google. You have internet with you. When you go and do all these kind of other searches, you can actually sit and actually prepare a report, because students come and ask me, parents are actually very afraid, or parents who doesn't know about instrumentation, so they are not allowing me, and all this. So because parents' side, they're only exposed to few other major departments, they are not aware of it. So what I suggest the students is, sit down, Google, see what is instrumentation, what are the subjects are there, what are the people who did instrumentation are in there. Prepare a report. And there was one kid who came and said that he actually prepared a report and everything and submitted to the parent, and then said, this is why I'm choosing. So that amount of clarity will be there when you sit and do a research, when you talk to people. So this video is something which is coming out, you can actually show and get points from here. There are other things that you can go and explore, and you can actually show to the parents. You get a clarity. So first, make sure you get a clarity why you're choosing it. What are the different subjects that covered in instrumentation? What will happen after you complete instrumentation? What are the other things which are there? If you have that clarity, and actually you can convince yourself first, and you can convince the people around you to take instrumentation. So with that, a small note, I would like to thank Dr. Vimla Juliet ma'am, HOD Electronics and Instrumentation, for conducting this, for taking initiative to conducting this, and thanks to Asunta ma'am for coordinating the whole stuff for the past week and bringing all together. Thanks to Neela sir for taking time out from your busy schedule and then being a part, and thanks to Himanshi, thanks to Rashi, for being there, and thanks to Manoj from joining from overseas in US. So thank you everyone who is actually be there seeing us live and who's gonna see after this. Thank you so much. Have a great day. Do research and don't worry, kids. It's a tough year. We all know, but you are completing and you are actually into the post-COVID, which is gonna see you a new world, and you are gonna be an architect of it. So in that way, you are actually so lucky that you're gonna architect of the post-COVID world. So stay hope, stay confidently, and stay safe, stay healthy. Wash your hands, maintain social distance. Thank you so much. Bye-bye. Thank you, everyone.
Thank you thank you, all of you.
Thank you. Thank you, everyone.
Thanks, man.
Thank you.